Good evening, students. So today our topic is non-deterministic finite automata in theory of computation. Non-deterministic finite automata. So before going to these topics, everyone know about what is finite automata. A finite automata is a machine that travel from one state to another state for a input. So 1 to 1 path. So one input, one new state. From old state to new state, it changes the state of the machine or mode of the machine for a particular input. That is known as a finite automata. So this finite automata have two types. The first one is deterministic finite automata. The second one is non-deterministic finite automata. So NFA or NDFA, that is known as NDFA, non-deterministic finite automata. The finite automata are called NFA when there exist many paths for specific input from the current state to the new state. So for a specific input, it have many paths from current state to new state. For a particular specific input, it have many new state, that is known as non-deterministic finite automata. So it is easy to construct. So for a particular input, it go to one or two multiple new state. So it is easy to construct the NFA when compared to DFA. So the both NFA and DFA is designed for a regular language. So the every NFA is not a DFA. Every NFA, non-deterministic NFA, is not easy to convert to DFA. But each NFA can be translated into DFA. But we can translate or convert from NFA to DFA. But from DFA to NFA, we can't to convert. So this is the definition. This is the formal definition for non-deterministic finite automata. So this is a combination of 5 parts, 5 tuples. The finite deterministic automata, non-deterministic finite automata M can be represented or can be definition by Q, sigma, transition, Q naught, F. So the first symbol Q is a set of states. For example, each machine must have two states, on, off, intermediate, like that. So on, off is the two different states. Here we represent the state in the name of Q1, Q2, Q3. The second symbol, sigma, is nothing but the input alphabet. Is a set of symbols. The set of symbols called as input alphabets. The third one, a transition symbol. Transition occur from current state to new state for the particular input, that is known as a transaction function. So from one state to new state, we travel for particular input, that is known as a transition function. It can be represented as the state into input symbol extends to 2 power q. The next fourth symbol, Q naught, it always point to the starting state, initial state. As same as the fifth element F, it always is a set of final state. This is the ending state. So Q naught is my starting state and F is the ending state. Okay, this is the formal definition for NFA. Non-deterministic finite automata has 5 tuples. The first one, finite set of state Q, set of symbols like input sigma, transition states, starting state and the final state F. So this is a simple example for non-deterministic finite automata. So there are 3 states with the name of Q0, Q1 and Q2. So how many states are available? 3 states, Q0, Q1, Q2. the starting state always marked by arrow mark. So always marked by arrow mark. So this Q0 is the starting symbol. So the Q0, Q1 have only one circle. So why here we use the two circle for Q2? So it represents something. So the double circle state acting as a final state. Q2 is acting as a final state. So by using the double circle we can know which one is the final state or ending state. For particular input, it can travel from one state to another state. For input 0, Q0 travel to Q1. At the same time, so Q1 travel from Q1 to Q2 for the particular input 1. But both input 0 and 1 is a Q2 travel itself as like cycle. Q2 it again and again treat itself. Okay, this is the first example. So next go to second one. So here we also have a 3 state. The starting state Q0 and the ending state Q2. Okay, for the single input 0, it go to 2 states. The Q0 move to 2 states for the single input. That is known as NFA. For example, for the input 0, it go to Q1 and it go to Q0 itself. Okay, as same as for Q2, this is acting as a final state. For a particular input 1, it go to 2 states. So one is itself, the second one is go to Q1. This is known as NFA. For particular input, it have multiple paths from one state to next state. So very important. The NFA is same as DFA, but the following two exceptions. It contains multiple next states for a single input and it contains epsilon transition. It contains epsilon transition means it can travel from one state to next state without any input. That is known as epsilon transition. So now we see about graphical representations of NFA. So an NFA can be represented by diagram that is called as a state diagram. The state is represented by vertex circle. The arc labeled with an input character show the transition. Okay, so the edges, connected vertex edges are always labeled with some input. The initial state is marked with an arrow. Just we see the example. The initial state is marked with arrow and the final state is denoted by double circle as shown in the example. Okay. So, non-deterministic finite automata can be represented using graphic representation, table representation, transition function representation and the equation representation. Here we have 3 states, state A, B and C. It have some edges with the value of 0 and 1. 0 and 1. So the input is 0 and 1. The arrow mark point the starting state, the Q0 equal to A. So A is my starting state. It represented by arrow mark. F value C, that means the C is double circled. The C is a final state. So graphical representation, equal representation. By using the both, we go to transition table. So the row represents the how many states are available. The column represents the how many inputs are available. For first row, the state A have transition function for the input 0. Input 0. When you 0 to state A, it go to A and B. So it go to itself and go to new state B. So when we give 1, it again go to state B. The second row for the state B, when you give 0 it go to C, when you give 1 it go to both A and C. For particular input it go to multiple states. The same as the last state C have multiple output for the input 0 and only one output for 1. So this is a simple example for NFA. Thank you students. I hope this is a very useful for you. Thank you students.